In this video, we are looking to find two different compositions. The first is h of x, which is defined as f of g of x. So let's start with that one. So h of x defined as f of g of x, that's that open dot, which can be rewritten as f of g of x. And I actually prefer the second way of writing this notation because it's much clearer which function is inside. Here, function g is inside of function f, which means we're going to take function g and it's going to become the input. So we are going to substitute it into function f everywhere that we see an x. So this is going to become the square root of, instead of x, now we're going to put function g in here, which is 4x plus 4, and then we'll have the rest of function f, which has the plus 5. So this means that function h of x will become the square root of 4x plus 9. That is our new function, which was a composition of these two functions that were given to us. Now we need to find the domain. And since this is a square root function, we do have some restrictions because we cannot have a negative inside of a square root. Now remember, 0 is okay. You can have 0 inside of a square root because the square root of 0 is just 0. No problem. But negatives are not okay because those give us non-real answers. So that means that what is inside the square root, which is the 4x plus 9, it cannot be negative, so it must be greater than or equal to 0. So if we solve this inequality by subtracting 9 and then dividing by 4, we see that x must be greater than or equal to negative 9/4. Now, it's also important to remember when we're doing the domain of a composition that we must also include the domain of the inner function, the function on the inside, because this was the function that we started with. So if we go back to the original function g, we'll notice that the domain of function g, since function g is linear, it's just 4x plus 4, the domain is all real numbers. So this means there are no additional restrictions for the domain of function g, so therefore we don't end up with any additional domain restrictions other than that x must be greater than or equal to negative 9/4. Now to write this in interval notation, if you struggle with interval notation, I recommend that you go ahead and plot this on a number line. So if we are looking for x to be greater than or equal to negative 9/4, that means we'll include all of the values to the right of negative 9/4 because those will be larger. And then we would choose a bracket here on negative 9/4 because of the equal to, greater than or equal to negative 9/4. So as an interval, this domain would be written bracket negative 9/4 to infinity. And if you want to be even more advanced with your notation, you could write x is an element of this interval. So this is the second half of our answer. This is the domain written in interval notation. So now let's move on to the second part of the question, which was asking us to find capital H of x, and that was the composition g of f of x. So capital H of x, which is g of f of x this time. And again, I'm going to rewrite that with the parentheses. That would be g of f of x, written like so. And once again, I really like that notation because we can clearly see function f is on the inside this time. So let me erase what I circled before here. And let's look at that substitution. Function f is being substituted into function g everywhere we have an x. So instead of 4x plus 4, we are going to end up with 4 times this new function that we're substituting in, which I'm putting in red. That's the square root of x plus 5. That's function f. And then we need to finish up function g, which had an additional plus 4. And there's really no simplifying to be done here. In this case, we're done. So capital H of x can be rewritten as 4 times the square root of x plus 5 plus 4. So now we need to do the domain here as well. And we'll notice that x is inside of a square root function. So we have the same restrictions as before. We cannot have any negatives inside of a square root. So what is inside the square root, which I should mention, the mathematical term for that, that's called the radicand. The radicand is what is inside the square root, and that radicand must be greater than or equal to 0. So x plus 5 must be greater than or equal to 0, which means x must be greater than or equal to negative 5. And again, if you want to see that on a number line, if x is greater than or equal to negative 5, then that arrow would be pointing to the right of negative 5, and then we would have a bracket here on negative 5 to include it. So that would be everything to the right of negative 5. However, again, we want to make sure that we are including any domain restrictions of the inner function. So if we look at g of f of x and consider the inner function, which is function f, we need to also include any domain restrictions for function f. So if I go back to the top and I take a look at our two original functions, let me erase the domain of g. I'm not considering the domain of g right now. I need to consider the domain of f. So looking here at function f to consider its domain, it turns out that the square root of x plus 5, that's the same domain restriction we just did, because we cannot have a negative inside of a square root. So x plus 5 must be greater than or equal to 0. X must be greater than or equal to negative 5. So the domain of function f is also from negative 5 to infinity. So we don't get any additional domain restrictions when we consider the domain of the inner function. So therefore, the domain of function capital H, h of x, which is our composition, the domain here would just be all values of x in the interval from negative 5 to infinity with a bracket on negative 5.